This mud can save your life. The science of ceramic water filters. Every year, millions of people get sick and hundreds of thousands die from drinking water that looks just like this. The enemy is invisible. Bacteria like E. coli, viruses, and protozoan cysts that cause cholera, typhoid, and dysentery. But the solution can be surprisingly simple. This isn't just a piece of pottery. This is a highly engineered public health tool, and its secret power lies in the fascinating science of porous materials. Today, we're unlocking the secret of the ceramic water filter. The ingredients, more than just mud. To build this filter, we need just a few simple, local ingredients. First, clay. This is our base, the matrix that will form the rigid structure. And this is the magic ingredient, a combustible material like sawdust or rice husks. On its own, it's just fuel, but when we mix it with the clay, it becomes the key to creating a microscopic maze. We combine these with water, form them into a pot shape, and let it dry. It looks solid, but inside, the sawdust particles are trapped within the clay network. The transformation, fire as a micro-tool. Now for the alchemy, we fire it in a kiln. As the temperature soars, two things happen. First, the clay particles sinter. Sintering is when solid particles fuse together at their points of contact without completely melting. This creates a permanent, strong structure. And second, the sawdust burns away completely. It doesn't just disappear, it leaves behind a network of interconnected pores. We've used fire not to add something, but to strategically remove material. How it filters. So how does it work? When contaminated water is poured in, gravity pulls it through this micromaze. The size of the pores we created is the critical factor. The pores are small enough to block pathogenic bacteria like E. coli and cholera, and larger parasites like Giardia and Cryptosporidium. They are physically screened out, trapped in the ceramic walls. The water that drips through is visually clearer, and more importantly, microbiologically safer. Many effective designs also include a final step, coating the filter with colloidal silver. The silver acts as a disinfectant, killing any bacteria that might remain on the ceramic surface, adding another layer of protection. This isn't just a lab curiosity, this is appropriate technology. It's low cost, uses local materials, doesn't require electricity, and can be maintained by a community itself. It turns abstract public health into a tangible, manageable tool